Okay, guys, so we are on our first journal here. So the first problem is just asking you to name that type of angle. So on here, there are three angles, and let's start with this one here. So in geometry, you should have learned three distinct angles. And the first one here is what we call a acute angle. And acute angles basically are angles where this angle, let's call that angle theta, is between the values of 0 and 90. So it can't be 90 or else it's something else. And it can't be 0, so that's just nothing. So it's always between 0 and 90 degrees. Let me put that degree sign on there. And so that's why I don't have that equal or that line underneath that inequality. So acute angles are between 0 and 90. And then this here, notice how there's a boxy angle here. So that means that this must be a right angle, is what we call it. Right angles are a very special type of angle where the angle is equivalent to or equal to 90 degrees. And then last but not least, we have an obtuse angle. And an obtuse angle is any angle, or theta, is between or has surpassed 90 degrees but less than 180. If you guys remember, an angle that's 180 is a straight line. So an obtuse angle is anywhere between that 90 and 180. So it's not quite a straight line or a straight angle yet. So those are our three distinct angles, and you will actually be doing a project where you will be finding an obtuse angle in the real world and taking a picture of that and then measuring it. We'll talk more about that Friday or Monday, so stay tuned for the more details. Right. So rolling into our first definition here, we talked about it on the first day of math class, where we talked a little bit about complementary and supplementary angles. And you should have heard of these angles in your geometry class as well. Now, the first definition here says the sum of two angles is 90 degrees. The angles are called blank. So anytime it's summing of 90 degrees or summing up to 90 degrees, that is your complementary angles. When they sum up to 180, that is your supplementary angle. Okay, so now that we have our definition down, let's see if we can solve some of these problems. So in this chapter, it's going to be asking you find the complementary and the supplementary angle with I think it should have said given the angle here. So my bad if that's a bit bad wording. Anyhow, so I have 60 degrees and I need to find the supplementary and the complementary angle for that. So let's just think about this for a sec. So let's think about a complementary angle. So a complementary angle is 90 degrees. So let's just draw ourselves a 90-degree angle like this, right? Kind of boxy like that. And 60 degrees of it, so let me cut this where I take up 60 degrees. So I'm going to say that this is 60 degrees. So if this is a complementary angle, right, that means that this part is 60 degrees, and I need to find what angle here makes this entire thing equal to 90 degrees. So how would I do that, right? Well, it's pretty simple. I would just take 90 degrees and subtract it by 60 to find what's left over, which is 30 degrees. So this here is 30 degrees. So that's exactly what I'm going to do here. So maybe let me organize this so it's a little bit more easy to read. So part A is finding the complementary. I'll just abbreviate complement and supplement. Yeah, I'll just do that. And so if I want to find the complementary angle, I'm going to be taking 90 degrees and subtracting it by the angle that I'm given, which is 60. And so if I subtract that, I get 30 degrees. And so my angle is 30 degrees, and I'm going to box that in. If I have supplementary, well, now I'm dealing with a 180 for the sum. So now I'm taking 180 and subtracting it by the angle that I'm given, which is 60. And so that's going to give me 120. So the supplementary angle for 60 is going to be 120. And so I've solved that. I'm going to do the exact same thing for number 6 here. This is 89 degrees. So again, I need to find the supplementary and the complementary. I'm just labeling things here. Part B, supplementary. So in this case here, remember, complementary is out of 90 degrees. So 90 minus the angle that I'm given, which is 89. And if I subtract that, that's just 1 degrees. So that's my complementary angle to the 89. And then for supplementary, I'm just taking 180 subtracted by 89 again. And that's going to give me 91 degrees. And there we have it. So hopefully that gives you kind of an idea of what we're looking for when I'm asking you for the complementary and the supplementary angle to a given angle. All right, let's take a look at some other examples just in a different question style. All right, so these problems here, you might need to zoom in on these graphs. So now you're given graphs with some algebraic expressions, and we need to figure out what's that unknown angle. So what they're talking about is they want to know what's the angle right here and what's the angle right here. So let's kind of like figure out how we can set this problem up. First thing is to determine whether something is complementary or supplementary. So when you're looking at this, graph here, notice how it's a straight line. When I add up these two angles, what angle should I get? So if you thought 180, you're correct because it's a straight line, right? So when you add up these two angles, you should get 180 degrees. So that means if I were to add 7x with 11x, I should get 180, right? So let's set that up like an algebraic problem. 7x plus 11x equals 180. And let's try to solve for this, right? Because we can combine like terms here. 7x plus 11x gives me 18x equals 180. And then, well, I need to get the x by itself, so I have to divide by 18. That cancels. So x is equal to, well, 180 divided by 18 is 10. But hold up. Nowhere in this question do they ask us what is x. They ask us what was the angle for each side. So if I want to know what this angle is, I'm going to need to plug in this x value into that 7x. So that's what I'm going to do here on the side. So 7 times 10, when I plug in that 10 into that x, is going to be 70, or 70 degrees. And then if I plug in 10 into the x for the 11x, I get 11 times 10, 110 degrees. And now I got the angles for both sides. So this here is my answer. Now, I just want to say you can always double check your answer because you know this is 180 degrees, right? So when you add these two numbers, 70 and 110, you should get 180. And you do. But here's also another thing to think about. Let's say for a second, I don't have this answer. I just plugged in 10 into the 7x and I got 70. So I only have 70 right now. If I want to get the other angle and I know this is supplementary, can I just take 180 and subtract it by 70 to get that 110? Yeah, I can. So you don't even have to plug in that 10 into the other equation. You could just subtract the angle you got from that 180. So, tip there. Let's try out problem 14. I'm going to have to erase this so I can make some room here. Or maybe, let's see here. I think I can make this smaller. Oh, nope, I just copied that. That's not right. Nope, I can't make it smaller. Never mind. Well, I guess I'm going to have to erase. Okay, So this problem here, number 14, we're going to do the same thing, but first ask yourself if this is complementary or supplementary. So when I add up these two angles, because it's on a straight line, it has to be 180 degrees. So that means I'm going to combine the two algebraic expressions. So the 20x plus 10 plus 3x plus 9 equals 180. And then I'm just going to try to combine like terms here. Like the 20x added with 3x, that's just 23x. 10 plus 9 gives me 19 equals 180. Then I would need to try to get the x by itself, so maybe move that 19 over. That cancels. So 180 minus 19 is 161. 23 comes down, or 23x, and now I need to divide by 23. So x is equal to, well, let's see what 161 divided by 23 is. I'm grabbing my calculator here, and that is 7. So I get 7 here. Now, remember, I just got x, and that's not my answer here. I need to plug that x back into each expression to get my actual angle. So let's write that out here. So this would be 20 times 7 plus 10. If I work that out, 20 times 7 gives me 140, plus 10 is 150 degrees. Now, remember what I said before. If I want to find the other angle here, I could plug in 7 into this equation, or I could just take 180 and subtract it by the angle that I got, which is 150, right, to find what's left over. And so that's really 30 degrees. And so this here are my two complementary angles. So this one here was 150, this one here was 30. Right? That's a little bit faster to do when you're subtracting it from the supplementary. Okay, last one here. We got this one, which looks a bit more boxy because this here is a complementary angles, right? These two angles added together is going to give us 90 degrees. And so I'm just going to mark that here. Well, just like before, we're going to add these two expressions together, but this time around, we are going to set that equal to 90 degrees. So we're going to add that and set that equal to 90 degrees. Okay, so given that, we're going to work this out. So 4y plus 2y gives me 6y, 90. If I divide by 6, y is going to be equal to 90 divided by 6 is 15. Now I have to plug that 15 into the expression. So I'll take that 4y. So that would be 4y, or 4 times 15 equals 30 degrees. Oh, well, okay. So if this is 90 degrees total, I subtract that 30 that I just got. That means the other angle had to have been 60 degrees. So my two complementary angles are 30 and 60. So that means here, oh, hang on. I just messed up, didn't I? Oh, Miss Chang just messed up. I think I did my math wrong. So this here, 4 times 15 is not 30. It is 60. My bad. So let me go ahead and erase that guy here. These things do happen, my bad. And so that means that we're really doing 90 subtracted by 60, which is really 30 degrees. There we go. So this would have been 60 degrees. This guy would have been 30 degrees. And there we have our two complementary angles. All right, and you might notice there's this little note down here. It's just to help you out. It says to determine whether you need to set the equation equal to 90 or 180. That's me just saying, like, when you're given these graphs, first determine, are you dealing with a supplementary, or are you dealing with a complementary? When you determine that, then you know what to set the expression equal to, or the equation equal to. And then you can solve for the variable, plug it back in to solve your actual angles. I hope that helps you out. Let's do a couple more problems that are more word-like problems. Okay, by the way, if I haven't mentioned this yet, all these problems, I'm actually doing it from your homework problem from chapter 14.1 problems 1 through 24. You can find these textbook problems on the Google Classroom under that spreadsheet for the schedule. So let's see what we need to do for this problem here. So automatically, I see that we have a complementary angle with measures of, it looks like 6x minus 4 and 8x minus 12. So it wants to know what those angles need to be given the expression. So I know right off the back, I'm dealing with a 180 angle supplementary, so they need to add up to be 180. Well, I'm given two expressions. So when I combine these two expressions, or when I add these two expressions, I should get 180. So I'm going to set them up just like I did before. So 6x minus 4, 8x minus 12, put a plus sign between them because I'm joining them, and setting that equal to 180. Or, well, you don't need that degree sign. So let's try to work this out by combining like terms. So that 6x added with 8x gives me 14x. Negative 4 plus negative 12 gives me negative 16 equals 180. Now, you always want to try to get that x by itself, so I got to move stuff over. So let's start with that minus 16. So I have to add 16 to either side. That cancels. So I have 14x equals 196. I'm going to divide that by 14. If you didn't know, 196 divided by 14 is going to be 14. So I got my x, but I'm not done. I got to plug it back into these expressions to get what my actual angles are. So I'm going to just choose the 6x minus 4 to use. So 6 times 14 when I plug in that 14 into x. I'm going to work this out. So 6 times, get a calculator here, 6 times 14 is equal to 84. Minus 4 gives me 80, so 80 degrees. Now, because I'm working with a supplementary angle, I could just take 180 and subtract it by 80, and that's just 100 degrees. And so I know that these two angles are my supplementary angles. Same thing for complementary. I'm just going to do it the same way, only that this is now setting it equal to 90. So I'm going to take my two expressions, combine them. And put a plus sign in between that and set that equal to 90. And then when I combine like terms, I got that 3x and the 6x. Combine that, I get 9x. I got that negative 5 and negative 40. So that when I combine them together, I get negative 45 equals 90. So what I need to do is get that x by itself. So add that 45 to both sides. That cancels. So I have 9x equals 90 plus 45 is 135. And when you divide 9 by 135, you get, I'm going to grab my calculator, 15. Okay, so we got x, but we need to plug that in to one of our expressions. So I'm going to choose the 3x. Oops, let me grab a pen. So 3x times 15 minus 5. So 3 times 15 is 45 minus 5 is 40. So we got 40 degrees. And because these are complementary, we can take 90 and subtract it by the angle that we're given, or just solve, so that's 40. And so the other angle must have been 50 degrees. And there we have it, our two complementary angles. All right, now, so I've done a few of these problems straight from the homework to help you kill some of your homework or cut back on homework. But try out the other problems that are in this section. You can find that on that Google spreadsheet. So I hope that helps you out, guys. Have a wonderful day.